Hi everyone, welcome to a new module on sets, maps and hash tables. In the previous set of modules, we covered linear ordered data structures that include lists, stacks and queues, and then we started with non-linear ordered data structures that include trees and its variants. In this module, we are going to cover our first not ordered or non-ordered data structures that include sets, maps and hash tables. These data structures are widely used and they will help you in solving a variety of problems, which include not only problems specific to sets, maps and hash tables, but also sometimes, like when you implement trees, graphs, lists, stacks and queues, you can actually back that up by a set or a map kind of data structure. So let's get started with the sets first. So set is, the idea behind set is exactly the same as you might have seen in some of your mathematical or statistical courses, which is set is a collection that contains no two duplicate elements. So you can think of it as a box, and if you try to add elements into this box, like let's say if I want to add S1, if I add S2, if I try to insert S1 again, nothing will happen to this set, which is it will just have one copy of the set rather than two. Set objects are typically not indexed, which means that you cannot have random access that you had in arrays in sets. So like let's say if our set is called set S, so we cannot do something like S of I, like that is invalid because you cannot just randomly traverse inside a set and it has no indices for each of its elements. Another thing is set does not reveal the order of insertion of items, which means that like if there are S1, S2, S3 in the set and we already have an existing set, we cannot tell whether S1 was inserted first, S2 was inserted first or S3 was inserted first. It could be anything, and the ADT or the interface that is provided by the set data structure doesn't confirm what is the implementation behind the scenes. The third thing is they do provide relevant, efficient search and retrieval of information, which means if we try to access something like whether S3 is a member of this set or whether S2 is a member of this set S, it provides really fast searching mechanism or fast retrieval of information. Similarly, if you want to add some information to the set, it is really fast. Also, they do allow removal of elements without moving other elements around. What that means is, let's say if S2 is deleted, there doesn't have to be necessarily shifts of information, which is now S3 doesn't have to be moved to its place or something like that, which is we don't care about how it's implemented behind the scenes, but it won't be removing elements surrounding if we are trying to remove a particular elements. So I'm going to take a concrete example here, which is like let's say if you have a set of like objects that contains maybe a fruit class which describes what the fruit is. So in this case I have a set that consists of some fruits, and you can see none of them are being repetitive. Now the set ADT, when we talk about the set abstract data type, which is in the first few weeks we discussed that all data structures have an abstract data type which provides like an interface. Set ADT consists of three different kinds of operations. The first one here, which is in this box, shows the operations which are common in almost all libraries. So like let's say all programming languages like C++, Java, they have their own implementation of the set interface, which is available as a part of standard template library or as a part of the collections framework in Java, or in Python there is also like sets. All of them will provide most of these operations, which include the find operation. So like let's say if we have a set called S that has some objects S1, S2. So what the find operation does is if we call something like s.find S1, it'll tell us whether S1 is a part of the set or not. Adding one adds an element to the set, so it might be called add or insert. So if I do something like s.insert S5, it's going to push S5 into the set. or like S5 will now be a member of the set. Remove operation removes an element from the set. So if I do something like s dot remove, it removes S3 or whatever from the set if it is in the set, otherwise it might return true false. We don't care about the specific implementation, we are going to see the specific implementation very soon. The second set of operations that are provided by the set ADT is what happens if we have two sets which are like, let's say if we have two sets that's called S1 and S2. Don't confuse S1 and S2 with this. So let's say they are two independent sets. What can we do with like two collections or two independent sets? We can have a union operation which joins them, an intersection which finds what are the common elements, and the difference which we are going to see very shortly. Also, there's this third operation which is also frequently used, which is returning a subset. So if I ask you whether S2 is a subset of S1, like it might return true or false, or if I ask you to generate a subset of a set, the function will basically return a subset. So I'm going to describe, just to give you a refresher on what these set operations are. Again, like these are really similar to the ones you might have seen in your high school or in the courses here at UF. So union operation, that's the first one. So union operation of two sets, like let's say if I have two sets that's called A and B, what it does is it combines both the sets, which is it consists of elements in A and in B. Both of them will be present in the final result. So in this case I have a lemon, strawberry, grapes, lemon and apple. You can see I have lemon has two copies, but it only has one copies in the final operation of the set. Strawberry is there, then grapes is there, and then apple is there. So that's how it's going to be. Intersection is the set whose elements belong to both A and B. So what are the common operations? And it's denoted by this symbol, which is A intersection B, while A union B is called the union of the set. So in this case, lemon is the only object that is common in both the sets, because strawberry is in this set but not in this one, grapes is in set A but not in B, and apple is in set B but not in A. So technically the result of our operation will be a set that contains just the lemon. The other two operations that are commonly used are the differences of the set, which is those elements that belong to A but not in B. So in this case, what we are going to do is we are concerned with all the elements which are in this set. We are going to see if that is in the other set. So if lemon is in both sets, then it will not be in the final set. While strawberry is in this set, it's not in this one, so it will be in the final set. Grapes is in this one and it's not in this one, so it will be in the final set. We don't care about apple because we are doing the operation A minus B. If it was B minus A, then probably the result would be just an apple. That's the gist of it, which is the set whose elements belong to A but not to B. The final operation is the subset operation, which is set A is a subset of set B if every element of set A is also an element of set B. So in this case, lemon, strawberry and grapes belong to this larger set, like this is set A and this is set B. So we denote that A is a subset of B, which is in this case written as like this with this notation. So let's say if we had a kiwi in this and kiwi is not there in the set B, then we would write this as A is not a subset of B, which is written as this notation. In the next video, we are going to discuss some differences between list and sets, and then we are going to discuss how sets are implemented in C++. Thank you.